Okay, so we're moving on from sequences, and we're going to start talking about series today. You do need to have your reference sheet out. There's going to be a formula on there that you're going to need. Okay. A series is simply the sum of the terms of a sequence. The fundamental definition notation of a series is shown in that box below. What is that funny symbol called again? Sigma or summation. And what does summation mean? The sum. You got to add up, well, your face this one. You have to add up all of the terms in the sequence, okay? So that's essentially what we're going to be doing. And if you look on your reference sheet, you should see a formula for sum of a series. Do you see it there? There should be two of them. Yeah, okay, so you're going to be utilizing those quite a bit. All right, so let's take a look at the first question. We've already done this, so now this is going to be review and kind of tacking on to what we have been doing in the past. All right, so given the arithmetic sequence defined by a sub 1 equals negative 2 and a sub n minus 1 plus 5, what? Okay. Then which of the following is the value of, and this means, this s sub 5, the sum of the first 5 terms, okay? And we're using the summation from 1 to 5 of a sub I. Who remembers how to write this out? A sub 1 plus a sub 2. Yeah. Good. And why am I stopping at a sub 5? Yeah, that's your upper bound, right? A sub 5. This value here tells you where to stop. This value here tells you where to start. Now here's my issue. I need to know what a sub 1, a sub 2, a sub 3, a sub 4, and so on are, right? So I have a nice formula that I'm going to use. I know what a sub 1 is. It's an equation. Yeah, we got you. There's no equal sign? You don't see equal signs here?
Oh, I thought you meant the one below it.
I should put s sub 5 equals. Gotcha. All right, so how do I find a sub 2? I just got schooled. What?
Oh, okay, wait.
That would be nice on the video, right? All right.
Oh, okay, you do -2 or a -2 plus 5.
Good. A sub. Okay. I'm plugging in -2 for a sub n minus 1, and I'm adding 5, and I'm getting 3. Good. How do I find a sub 3? 3 plus 5, which gives me geniuses. A sub 4, which gives me, no, 13. Ouch. All right, a sub 5. Good, which gives me, good. What am I going to do with all those numbers? Yeah, because a sub 1, right, is -2 plus 3 plus 8 plus 13 plus 18. I'll make it an equation for you, Mr. Zulum. So what does s sub 5 equal? 40. What do you think? Summation's not bad. Just remember you have to go from the lower bound to the upper bound and add everything up. Okay. Ready? Yes or no? Yes? Okay, so the sums associated with arithmetic sequences known as arithmetic series have an interesting property. It's all that interesting. Many applications and values that can be predicted with commonly known rainbow addition. Why do they call it rainbow addition? Because it looks like a rainbow. All right, so consider the arithmetic sequence defined by a sub 1 is 3 equals 3, and a sub n equals a sub n minus 1 plus 2. The series based on the first 8 terms of the sequence is shown below. Terms have been paired off. Notice how they're paired off, first with last, second with second to last, third with third to last. Got it? Say yes. Okay. So what does each pair of sums equal? 20. Why does it make sense that this sum is constant? No? Why does it make sense that every single sum is 20? What is the order? Why is it what is that 3 called? What do we call that 3? We have a common difference. So if it's going up by 3 going to the right, it's going to be going down by 3 going to the left, right? So it makes sense because we have a common difference. Yeah, we meant the common difference was 2. It's going up by 2, not by 3. I lied. Thank you. I was just going off what you said.
Oh, thanks.
You're welcome. The common difference is 2. I apologize. Okay, and so how many of these pairs are there? 4. You just count the rainbow. Okay. Using your answers from A and C, what would the sum of all the terms be? 20 times 4, which is 80, right? If the sum of each pair is 20, and you have 4 pairs, 20 times 4 is going to be 80. Okay? So, we can actually build an equation off of this. Can we call it a formula? Yes. Okay. So let's look at the formula. So, the sum of the first n terms is going to be the number of terms divided by 2 times the first term plus the last term. Okay, that formula is on your reference sheet, although it looks a little bit different, right? It's the same exact formula. Are we talking about geometric or arithmetic? Yep. Okay. So now let's learn how to use it. Ready? All right, which of the following is the sum of the first 100 natural numbers? What's a natural number? A number that is not unnatural. That's great. What? Counting numbers. What are my counting numbers? 1, 2, 3, 4. Does it include 0? No. Okay, so I want the sum of the first 100 natural numbers. So the sum of the first 100 natural numbers. So what's n? 100. Okay, very good. N is 100. What is my first number in my sequence? 1. And what is my last number? 100. Please find me the sum of the first 100 natural numbers. Yeah, I meant to write 2. Thank you. Sorry about that. I am off my game today. Sometimes these things happen. Don't worry, you won't be stuck with me for too much longer. 5,050. Good? We good? So question. All the stuff that we learned the last 2 days, does it just go away? We're not going to use it anymore? We're done with it? I mean, because that's how math works, right? We learn something and then we just forget about it and never use it again, right? Okay, so we're definitely going to be using what we learned the past 2 days. We're going to need those formulas that I told you had to memorize. So I hope that you have them memorized. Do you have them memorized? Uh-huh. I can see the lies in your eyes, but we're going to continue. The lies in your eyes. It rhymes. I should be an English teacher. Okay, so, no, I shouldn't. All right. Find the sum of each arithmetic series described or shown below. So the sum of the 16 terms is given by sum of 16 terms. Are you paying attention, boys? No, pay attention. Okay, hold on. So here's our formula, right? So I need to make sure that I have all of that information. So this is what you're going to do, and I'm going to be a stickler about this. I want you to write down what everything is, what they're giving you, what your knowns are, okay? The sum of the 16 terms given by, what's n represent? 16 is my number of terms, right? A sub 1? Negative 10, that's my first term. A sub n? 50, my last term. Where'd you get 96 from? Oh, I'm sorry. Okay, so do I have, pardon me, do I have all the information I need? All right, so we're just going to plug this one in then. Am I always going to have everything I need? No, that would be too easy. Find me my answer. Can I have somebody that agrees? Okay. All right, so let's look at the next one. Do you think this one's going to be as simple? Probably not. All right, the first term is negative 8. What's that represent? A sub 1. The common difference is D. Yeah, obviously. And that's 6. There are 20 terms. What's that? N. Do I have all the information? Here's my formula. What am I missing? I'm missing a sub n. Kind of need that, don't I? So how can I find a sub n? So remember when I just got done talking about how we need to know all of the stuff we learned the past 2 days? We're probably going to need a formula. Which formula do you think it is? You're saying this one, but I don't know what that means. The one that, okay, some of them have D's in them, but I would like the specific formula. Good, I need that formula. Because that formula is going to allow me to find what I'm missing, which is a sub n. Okay, so I have everything except for a sub n. What's a sub 1? What's my common difference? And what's n? 20. So really this is a sub 20, right? Okay, find me my value, please. $106. Can I have somebody that agrees? Okay. So now we have this, right? We have a sub n. Can I now find my sum of my first 20 terms? Yeah? Good, find it. Okay, so we're going to have 20 divided by 2 times what? And you got what? What? 980. Awesome. It's not so bad, right? Not so bad. All right, so let's look at C. The last term is a sub 12. A sub 12 is 29. I'm going to move this up. The common difference is negative 3. So what am I going to write down here? What do I know? I know a sub n, which is good. What else do I know? Good. What else do I know? I know n. What's n? 12. Good. What don't I know? A sub 1. That's what I need to find out first, right? So what formula gets used to find a sub 1? Yeah, which one? like the way you said that. Good. Find a sub 1, and then take that value and use it to find the sum of the first 12 terms. So running out of time. Okay, so we have a sub n. We don't know a sub 1. We have d, and we have n, right? We'll make that 11. So we get negative 29 equals a sub 1 minus 33. A sub 1 equals 4. We go straight to our formula. S sub 12 equals 12 divided by 2, 4 plus a negative 29, which gives us a value of negative 150. Excellent. How'd we do? Not bad, right? All right, the sum of 5 plus 8 plus 11 plus ... plus 7. What does that mean? Then you gave up? Okay. What does the ... mean? Yeah, there's more values in there. We just don't see them, right? Okay. So, tell me what I know. I know A1, yeah? A sub n is 77. D is 3. Good. What don't I know? And I don't know how many terms I have, right? How can I figure it out? I'll give you a hint. We've been using it. Yes, which formula? The same one, so this one here, right? So let's see if you guys can do this one on your own. Please go through, find the number of terms, and then find your sum. How many of you started like that? What did you do next? Subtract 5. Then what? Divide by 3, yeah. Which gives us 24. Then what? So n equals 25. How many of you got 25 for n? You can distribute and still get the same answer. Yeah. So I want S of sub 25, right? Means there's 25 terms. 25 divided by 2 times 5 plus 77. And what do we get? Good. We okay with that? We have one more example. What time is it? We got 2 minutes. Let's see how far we can get. All right, Kirk has set up a college savings account for his son Maxwell. If Kirk deposits $100 per month in an account, increasing the amount he deposits by $10 each month, how much will he have in the account after 10 years? All right, so what do I know from this? What's given? The starting value. Yeah, what does he have in the first month? $100. What else do we know? D is, he's increasing it by $10 a month. He's starting with $100 first month, increasing it $10 each month thereafter. It is worded weird. All right, what else do we know? N, well, it's 10 years, but we're talking in terms of what? Months. So N is going to be what? 120. All right, we'll finish this tomorrow, guys. Nice job today. Homework is pages 6 and 7. Make sure it gets done. It did not look like a whole lot if you had today's homework completed. I do notice these things.